What's going on, it's Suk and I'm back with a brand new video on SuperDuprTech, and in today's video I'll be showing you the results that I got when running a number of different benchmarking tests on the brand new M3 powered MacBook Air. As always, I am currently working on my gaming video for this MacBook Air, so if you are new around here and you want to be notified when that video goes live, then be sure to subscribe clicking the bell icon to be notified when that video goes live. But without any further ado, let's hit the titles. So first things first, I do want to get into talking about the spec for the model that I'm testing in today's video. So this is the 13-inch MacBook Air with the M3 chip, which has an 8-core CPU, an 8-core GPU, 8GB of unified memory, along with 256GB of SSD based storage. So the first few benchmarking applications which I threw at this MacBook Air from GeekBench, the first of these being GeekBench 4. Now GeekBench runs several different tests on this machine, and once these have been ran, it will then score the machine based on the time taken to complete these tasks. So when running the CPU test, it will give us both a single and a multi-core score. And when running this test, I got a single core score of 7,800 along with a multi-core score of 32,356. I then ran GeekBench 4's compute test, and starting off with the OpenGL test, I got scores of 109,403, but when it come to running the Metal test, I got scores of 102,704. I then ran GeekBench 5, and starting with their CPU test, I got a single core score of 1,735 along with multi-core scores of 8,307. When running the GeekBench 5 compute test, I got an OpenGL score of 26,093, and when running the Metal compute test, I got scores of 27,428. Running the latest version of GeekBench, GeekBench 6, and starting off once again with their CPU test, I got a single core score of 3,088 along with a multi-core score of 12,088. When running the OpenGL compute test, I got scores of 25,887, and when running the Metal test, I got scores of 41,565. So sticking to the trend of testing the CPU, I then ran a number of different CineBench tests. So starting off with CineBench R20, I got a score of 2,630. I then ran a slightly newer version of CineBench R23. Now when running this test, I got single core scores of 1,896 along with multi-core scores of 9,162, which indeed gives us a ratio of 4.83. I also ran the latest version of CineBench 2024. When running this test, I got a single core score of 139, and I also got a multi-core score of 588, which indeed gives us a ratio of 4.23. I then wanted to see how the 8-core GPU in this M3 MacBook Air would perform, so I ran a number of different graphics tests, and starting off with the 3D Mark wildlife test, I got a maxed out score along with it averaging 60 frames per second. But when running the wildlife stress test, I got a high score of 10,020 along with a low score of 10,017. I then ran the wildlife extreme test and got a score of 6,981 and got an average frame rate of 41.8 frames per second. Also from 3D Mark, I ran the wildlife extreme stress test, and when running this test, I got a high score of 6,984 with a low score of 5,406. So I think the most interesting takeaway here is the entry iMac, which has the exact same chip. The highest score it would achieve was 6,360 and the lowest was 4,902, which was around a 25% decrease in performance. And the interesting thing here is this MacBook Air with the same chip running the same test seemingly performed better, with it scoring 6,984 compared to the 6,360 of that iMac. But the interesting thing to take away is the difference between both of these machines' highest and lowest scores was around 25%. And you've got to keep in mind that that iMac has a fan inside of it, whereas this MacBook Air is completely passively cooled. I then ran the Solar Bay test on the MacBook Air, and when running this test I got a score of 11,203 with an average frame rate of 42.6 frames per second. which once again was higher than the iMac, which averaged 39.4 frames per second. I also ran the solar based stress test, and when running this stress test on this MacBook Air I got scores of 9,777 with lower scores of 8,997. And this time around iMac scored much higher, with its best score coming in at 10,342 compared to this MacBook Air score of 9,777. I then wanted to see how the internal SSDs in this MacBook Air would perform, so I ran a number of different disk speed tests. So starting off with the Aegis System speed test, I got write speeds of 2,880 megabytes per second with read speeds of 2,558 megabytes per second. I also ran the Blackmagic disk speed test and got write speeds of 2,104.8 megabytes per second with read speeds of 2,639.6 megabytes per second. I then ran a Wi-Fi speed test and got download speeds of 492 megabits per second with upload speeds of 73.3 megabits per second. I then ran NovaBench 2. Now NovaBench is a good general benchmark as it tests all aspects of the machine, be it the CPU and GPU all the way down to the system memory and the system storage. So when running this test I got a score of 962. I also ran the V-Ray test, and when running this test I got a score of 5,852. When running the AnTuTu HTML5 browser benchmark, I got a score of 92,731, and when running the Speedometer 2.0 test, I got a score of 696. I also ran Speedometer 3.0 and got scores of 36.8. So I then wanted to see how this MacBook Air would perform when it comes to doing some 3D animation work. So I performed a number of different timed render exports through Blender. So when starting off with the classroom test using the CPU, it took 12 minutes and 13 seconds to complete this, whereas it was much faster using the GPU with it taking 3 minutes and 7 seconds to complete. When using the latest version of Blender, Blender 4.0, to render the classroom scene using the CPU, it completed this in 10 minutes and 2 seconds, so it was a little faster compared to the previous version of Blender. Whereas it wouldn't complete this using the GPU as it simply said it had run out of system memory. With it failing to render the classroom scene through Blender 4.0, I decided to then use a slightly smaller project. So this time around I used the BMW scene, and when it came to rendering using the CPU, it took 5 minutes and 56 seconds to complete this, whereas when it came to using the GPU, it was much faster with it taking 1 minute and 20 seconds to complete this. But once again, when using Blender 4.0, it took 4 minutes and 19 seconds to complete using the CPU, whereas when it comes to rendering the BMW scene through Blender 4.0 using the GPU, it did it much faster with it taking 47 seconds to complete. I then wanted to see how well this MacBook Air would perform when it comes to graphical tasks, so I ran GFXBench Metal. Now GFXBench is quite good as it runs a number of different higher and lower intensive tasks both on and off screen. Now in the interest of saving some time, I have calculated the average of all of these tests, but as always I will show you each individual result. So the average I got for the higher intensive tasks was 176.31 frames per second, whereas for the lower level intensive tasks I got a score of 249.71 frames per second. I then ran the Shadow of the Tomb Raider benchmark across a number of set of resolutions and graphic settings. So starting off with this MacBook Air's native resolution of 2560 by 1664 and keeping the graphic settings to high, we got a score of 2591 with an average frame rate of 17 frames per second. When the graphics was lowered to medium, we got a score of 2778 with an average frame rate of 18 frames per second. And when running the test once again with high settings with the resolution dropping to 2560 by 1600, we got a score of 2671 with it averaging the same 17 frames per second. Lowering the graphic settings to medium, we got a score of 2806 with the same frame rate once again of 18 frames per second. And this was to be expected as I essentially lowered the resolution by a measly 64 pixels vertically. So of course, when dropping the resolution down to 1920 by 1200 and keeping the graphic settings to high, we should see an improvement across the board, which we did. and when running at that resolution I got a score of 4204 with an average frame rate of 27 frames per second, and when the resolution was kept at 1200p but the graphic settings was dropped down to medium, I got a score of 4329 with an average frame rate of 28 frames per second. I further lowered the resolution down to 1280 by 854, and when keeping the graphic settings to high I got a score of 6032 with an average frame rate of 39 frames per second. However, when running this benchmark at that resolution but dropping the graphic settings to medium, I got scores of 6361 with an average frame rate of 41 frames per second. I then ran a series of different tests from Unigine, starting off with the Heaven benchmark, and when running this test at 1470 by 952, I got an average frame rate of 83.8 frames per second with a score of 2112. When the resolution was lowered very slightly to 1440 by 900, I got an average frame rate of 75.1 frames per second with a score of 1892. I then ran the Valley test, and when running this test at 1470 by 956, I got an average frame rate of 73.7 frames per second with a score of 3085. And once again, when lowering the resolution down to 1440 by 900, I got an average frame rate of 71.1 frames per second with a score of 2973. I then wanted to see how this MacBook Air would perform when it comes to running a certain amount of tracks through Logic Pro. And you'll be interested to see that when it comes to running the Logic Pro benchmark, that this MacBook Air managed to run 89 tracks without crashing. I then used Lightroom to enhance and reduce the noise of 100 raw GH5 pictures. When it comes to doing this MacBook Air completed it in 1 hour and 12 minutes and 7 seconds. Once again, using Lightroom, I then ran the super resolution enhancement on 50 raw iPhone 15 Pro Max 48 megapixel photos, and it completed this in 1 hour and 15 minutes and 4 seconds. I also ran some timed video exports through Final Cut Pro, exporting a 5-minute 24-second video project down to H.264. So when exporting as a full HD project that's 1920 by 1080, it managed to complete this in 40 seconds. But perhaps the most interesting thing was when it comes to exporting the 4K video project that's 3840 by 2160, it completed this in 2 minutes and 53 seconds. So I think the most important takeaway from this is the battery life. So I started this video with the MacBook at 100% and it managed to run all the way down to Blender when it comes to running the BMW test through the CPU. In fact, this took it 3 hours and 54 seconds, which was quite interesting. So it pretty much means that regardless of what you're doing, even if you're completely stressing this machine to the maximum, that you're probably going to be looking at a battery life close to around 4 hours. So as you can probably tell, this video took quite some time to put together, so I'd appreciate if you could take the moment just to hit that subscribe button, clicking the bell to be notified of when a new video goes live. If you've got any questions with anything you've seen in today's video, then be sure to leave them down below in the comment section, or alternatively you can hit me up on my social media, links to which can be found down below in this video's description. Once again, thank you very much for watching, and I'll see you next time. Take care and have a good one.